So, ladies and gentlemen, welcome back from the afternoon break. We'll move on now with the next presentation. We have Keziah Plattner and Kadia Mashal. Ladies, all yours.
Okay, go ahead. All right. Hello, everyone. Welcome to our talk, Sisyphus and the CVE feed. Today we'll be talking about why you should be automating your vulnerability management work. So quick legal disclaimer, we are limited in what we're allowed to share or not. So feel free to definitely ask questions. Just a heads up, may have to limit, but we'll try to answer as much as we can. All right, introduction time. So my name is Keziah Plattner. I'm a senior software engineer at Airbnb. I've actually been there 6 years last month. Worked on things from vulnerability management, IAM access management, patch management. I describe myself as more of a builder rather than a breaker. So shout out there to all the hackers. You keep my job very interesting. And then a fun fact about me is that several years ago, I actually lived in Berlin for 6 months. So it was very nostalgic to see Club Mate.
Okay. And hi, I'm Kadia Mashal. I'm an engineering manager at Airbnb. I've been with Airbnb for over 4 years, actually born and raised in Austria, and moved 10 years ago to San Francisco. Yeah, so I definitely used to come with my parents to Budapest quite often. Definitely love the community, and thanks for hosting us.
So full disclaimer, if you're here to learn about Greek mythology, you will be disappointed. This is just a fun title. But if you're not familiar with the myth of Sisyphus, it's from Greek mythology. Sisyphus is a mortal who angered the gods by his constant trickery and cheating death. So eventually they do manage to punish him, and what they do is they force him to roll a boulder up a hill for eternity. But the moment the boulder reaches the top of the hill, it falls right back down. He has to go back down to the bottom and push it back up again. Essentially just a futile endeavor that will never be completed. If you're in the InfoSec industry, this might resonate to you a little bit. We may not be in hell pushing large rocks up hills, but it can feel like we're fighting a losing battle against never-ending streams of CVEs.
So before we talk about the automation and how we are dealing with the vulnerability lifecycle, let's talk a little bit about the fundamentals of a vulnerability lifecycle. So also quickly here, we all know there is no such thing as secure code. I mean, of course, if you delete your entire code base, that would be a win. But we obviously want job security. We want to implement a process where you can design and implement appropriate vulnerability lifecycle in your environment. So let's talk a little bit how this looks like. So all the hackers here, you break all the things, and we have to detect them, and that's usually the first step of the vulnerability lifecycle. So you detect a vulnerability. This can happen through various sources, for instance, scanners, bug bounty, pen tests, you name it. And then you assess the vulnerability. Is it applicable for your environment? Is it as critical as we think it is? And then the third step in the vulnerability lifecycle, which is the more common one in vulnerability management, is like metrics, where you showcase known attack surface and just share the metrics with the affected remediation owners. And one of the steps, the fourth steps, the most important step in our opinion, is the remediation step. Killing the vulnerability and making sure that you also prevent it from being reintroduced again. So this is the common vulnerability lifecycle. So what is our objective with this talk? So again, we work for Airbnb. We are a cloud-based company, which means we have to build a system that supports growing environments. Like any time you expand your environment, it means more assets, more vulnerabilities. So for instance, we wanted to make sure that we can adjust and adapt to the large stream of vulnerabilities that we constantly have to deal with. Another objective of ours was, let's make sure we don't just find the vulnerability, but we also make sure that we remediate it and address it in a timely manner. And also prioritization. all of you find these amazing vulnerabilities, but where do we start? What priority should we give each vulnerability? Especially, we all know CVE details, CVEs are not, default scoring of CVEs are not always applicable. Another objective of ours was the root cause. So understanding what introduced the vulnerability in the first place, it's more important than just patching it at the moment. And also, we wanted to be vendor agnostic. We wanted to build a system. It doesn't matter which scanner you use, which company you work with. We wanted to build a pipeline you constantly can expand on, regardless of the vendor limitations. So this awesome slide, you can tell I was not hired as a designer for Airbnb, but I was trying to showcase you what constant traditional vulnerability management looks like. So usually you have vulnerability scanners, bug bounties, subreddits, all of this mess that is constantly dropping on your plate. And most of the time you have one bottleneck, security engineering team, or maybe a TPM, technical program manager, who constantly just triages vulnerabilities and assesses the risk, and then shares it with the remediation owner. As you all can see, it's usually a bottleneck. So you are eventually, either you don't have time to reassess all of the vulnerabilities, or you're just going to be a bottleneck and take away from critical remediation time. So what are the challenges? As you all know, CVEs drop on I think probably CVE is dropping right now. So who here has looked at scanning reports before? Vulnerability scan reports? Okay, I'm sorry. But yeah, so definitely we all know it can be very challenging to go through this mess. So it can be very noisy. So the first challenge that we faced when we built our system, our platform, is risk assessment. Who here is familiar with CVE, CVSS scoring, security vulnerability scoring? Okay, great, that's the majority. So for the folks who are not familiar with it, each vulnerability that gets disclosed gets an ID, a CVE ID, and usually, most of the time, it also has a CVSS score that gives you a little bit more information or scoring about the attack type and the impact of the vulnerability. So most of the times, these are default scores that are not necessarily contextualized to your environment. Yeah,
a quick metaphor on how to think about what it's like dealing with having a scanner scream at you that a critical vulnerability has dropped. So this is the Winchester Mystery House in San Jose, California. It's famous for having been built by an eccentric woman who put a lot of weird features in the house, like this door on the second floor that leads to nowhere. So here we're at work, and we get pinged about a critical, like, look at this open door, it's wide open to the world, like, go fix it right now. But then we actually go look at the context of our infrastructure. Okay, yes, it is an open door, but it's on the second floor. Someone would have to bring a ladder in order to make it in. And we have different mitigations that would probably let us know that someone is dragging a ladder into our property before they even make it close to there. So this critical vulnerability, when looked at in more detail, is probably more like medium severity. But that doesn't mean it's not a critical for another company. If that door is on the first floor, then that is something you should be fixing right away. So imagine this constantly happening with never-ending CVE feeds, constantly getting pinged for criticals that are open doors on the second floor that you really can't get to.
Exactly. So it was definitely a challenge going with this default scoring that weren't applicable for our environment. Another thing that we also dealt with, a challenge, is inflexible vendor features. So we appreciate vendors, of course, great tools out there, but it's always so challenging to ask for features or integrate within our environment, because again, we have a unique environment at Airbnb, so plugging in a new tool requires a lot of adjustments. Also, most of the vendors, or the default ratings, have scores that are not necessarily applicable to us. And when you ask them whether we can adjust the risk scoring, most of the time the answer says, yeah, open a ticket and we'll work on the feature. But it's obviously a little bit of a challenge because it creates operational work. Also, we want to make sure that when a vulnerability gets dropped, that it gets reported immediately. So most of the vendors had limitations with their reporting integration as well. And if you remember the slide earlier with all of the security noise, think about it this way. Every time you plug in a new security tool or a new tool, it leads to operational work. You usually have a person or a team that needs to do the manual triage. Operational work was definitely a challenge for us. And also, the last step that we had to challenge with was accountability. How do you make sure that people actually fix the vulnerability? And how do you make sure that they're responsible and engaged?
All right, so with that in mind, our team tries to stick to general guidelines we prioritize while approaching this problem. These aren't set in stone, they're always exceptions, and we definitely do not accomplish them right away, but it's kind of a North Star we try to head in. So as we said earlier, without context, default severity scores can be inaccurate, creating what I'll call here a false positive. To be clear, I'm not saying it's not a vulnerability, but it might be a false positive in our context if it's difficult to exploit or doesn't apply to us. So just relying on something like a CVSS score is not sufficient to actually automate the risk. You still need human intervention to figure out the actual true risk in your environment. Now, it can be really tempting to want to catch every potential vulnerability by just looking at every single result given to you, marked as a high critical. I'll call this the maximizing true positive solution. The intention is good. It's better safe than sorry. But this is a misconception. Humans manually evaluating things aren't going to catch 100% of true positives either. There's alert fatigue. People can easily misread and misunderstand things. We're all in security. We all know humans are the weak link in a system. And a gap that you may not even be thinking about is that undisclosed vulnerabilities exist. Relying on detection as a way to catch every true positive is just never going to work as a sole vulnerability management strategy. And of course, not to mention, half the time the most severe vulnerabilities are dropped on Twitter with someone with an anime profile picture. So our biggest goal here is we want to create a system that does not rely on human intervention to triage risk. We want to focus on cutting out the human element as much as possible by automating the risk assessment process with our goal to ruthlessly minimize false positives rather than maximize true positives. This can make people feel nervous. What if something slips through the cracks? Like, is it better to, err on the side of caution? But as we said earlier, there is no human or automated process that would ever catch 100% of vulnerabilities. You need to accept that the futility of this endeavor, the boulder is never going to stay on top of the hill. And since 100% accuracy isn't possible, it's better to design a process that prioritizes remediation speed by focusing on automation and a low false positive rate, even if something could slip through the cracks. A quick exception, we do tend to manually triage criticals. It can be very difficult to actually tell the difference between a true critical and a high, but the overhead for manually triaging criticals is nowhere close to the overhead of having to triage everything. So this brings us to our next point. Accepting this principle means that you're accepting an imperfect detection strategy. So if we're focusing on minimizing false positives, that means we're going to be missing things. What do we do about that?
Definitely, as Keziah mentioned, it is impossible to address 100% of all of the vulnerabilities. We all know not every vulnerability has CVEs. There are plenty of 0 days out there that we do not know about. So it's definitely important to have something in place that pairs with your detection to balance the risk. So what we call it is pair detection with preventative measures, for instance. So what happens with potential misses? What we try to do is don't rely on vulnerability reports. So especially for the folks who here have seen, who raised their hands and said, yes, we have seen scan reports before. Most of the time, you should not need them to take action. So you should always pretend that your environment is vulnerable. So preventative measures can be, for instance, introducing a regular patch cadence. I think that's a common strategy. Patch Tuesday, very known. But we think it's even more important to have frequent image deploys. harden the image, and deploy regardless of the vulnerability report. Just make it harder to introduce known vulnerabilities over and over again. Build a system, especially for the devs here, make a system that makes the easy road the secure road.
On the other hand, all the automation in the world isn't useful if you antagonize other engineering teams. For example, you do have to balance security with developer productivity. Trade-offs are important. We don't want to be sacrificing the effectiveness of our engineering teams for low-priority security requests. Of course, that's within reason. I'm not saying that we should compromise security, but I'm saying that we should pick our battles and think of creative solutions that work for everyone. And it can help build relationships by trying to work to pair security benefits with other engineering goals. For example, you may have a team that has an internal tool and they're tired of maintaining old versions of it. If you work with them to get a patching cadence to make sure everyone is using up-to-date versions of that tool, it's great for us because they're not using software full of vulnerabilities, and it's great for them because they have less things they have to maintain at the same time. So we made a mistake of being too top-down, but that strategy has never been as effective as when you treat other engineering teams as partners, seek their input, and try to make it a mutually beneficial process.
Before we go, we will talk about the implementation details in a second, but just quickly, I want to also highlight accountability. So again, make sure that you have SLAs in your environment where you set expectations on when someone should remediate a vulnerability. Don't expect them to fix everything within a minute because that obviously doesn't make sense. Set expectations based on the risk. If a security vulnerability is a critical, they should be able to prioritize this over a low finding. Also, make sure that you're flexible with your service level agreement as well. For instance, if there is a vulnerability like the example that Keziah mentioned earlier, if you have mitigations in place, you should have a system that automatically downgrades the severity of the vulnerability, because again, that will also help individuals maybe take more time for the SLA, resolving the SLA. Also, another step that you should focus on is auto notifications. So I built a bot that just lets people know when they get a vulnerability assigned, also making sure that it happens quickly, because the worst thing that would happen is you sit on a vulnerability and the rest of the company does not know about it, especially the remediation owners. The last step here is metrics. Again, metrics is usually used to track vulnerabilities, but also a lot of finger pointing, letting people know that they are not performing well. Actually, you can sell it better by letting them know, hey, these metrics are showing that your team is behind with fixing the vulns. Maybe you have resource constraints. How can I help you? How can the security team showcase that you actually need more devs or more remediation owners?
And another sort of understated part of accountability is like finding the right owner to remediate. It's not always as simple as just a single asset to an owner. For example, in the case of containers and base images, it's not really helpful to tell someone you have a vulnerability in their image if it's actually from an inherited base image owned by someone else. So you do want to be thoughtful about how you're finding remediation owners, and you want to give vulnerability reports to the person most empowered to fix it. So with that all in mind, let's go into how we built a process to manage our vulnerabilities. So first step, aggregate and process vulnerabilities. Depending on your setup, you may have any number of scanners set up. They probably have different formats or different levels of information provided. As mentioned earlier, some scanners do have like automation features like auto reporting to Jira, but they usually are inflexible enough, or inflexible. They don't let us adjust things, and in addition, if you have multiple scanners, even if they have their own automation, they don't know about each other. So instead of just using a scanner out of the box with its default features, what we do is we import it, we standardize all the data, and we track every unique vulnerability with a UUID. That's a key part of how we're tracking a vulnerability through the lifecycle. Our general thought is that a UUID should represent an asset in a vulnerability. And this can be simplified. For example, it may not, instead of just tracking every single CVE in an asset, it can be useful to track the asset and the package version, because the package version has multiple CVEs, and just fixing that fixes all associated CVEs. So there's no need to have to manage so many of them. And then the UUID helps us even beyond the first fix. It helps with metrics. It can also help identify repeated violations or major gaps in our infrastructure.
So as I mentioned earlier, risk assessment was a challenge for us because all of these default CVEs scores just weren't necessarily applicable to us. So how did we solve it? So we do have an internal risk service where we try to collect metadata about our environment as much as possible. So for instance, the data that you can collect about an asset to have a better risk signal is, for instance, where does the asset live? Is it internal facing or is it externally facing? Also, what are the IAM roles? For instance, what type of access controls does this resource have? So if it gets exploited, how far can the attacker go? So we collect this data when we assign a vulnerability to have a better risk assessment about the vulnerability itself. Also, we collect data that the asset or the service is handling. For instance, is it a service that is handling PII? Then we have to obviously prioritize that and make sure that it gets prioritized in our system. Also, we collect within our environment information about the application vulnerabilities. For instance, does the service have several open vulnerabilities that could be exploited as part of the attack? And also infrastructure vulnerabilities. For instance, is it in a well-protected AWS account, or is it something that we consider a sandbox account, et cetera, et cetera. So there are a bunch of metadata that all of you should be collecting in order to have a better risk assessment. So quickly here, this is how we implemented it. So again, we collect in our platform that we build, we collect asset information. Again, is it externally facing, locally only? We also collect data about the attack type. So we break down the CVSS score. Most of the CVSS scores tell you whether it requires user interaction, whether the vulnerability or the exploit can happen over the network. Do you need local access? So again, we break down all of these attack types to have a better understanding of the vulnerability. And then we also leverage external scoring systems. So who here is familiar with NVD, National Vulnerability Database? Okay, sweet. So for the ones who are not familiar with it, it's basically a database, centralized database with a bunch of vulnerability information, and most of the time it's a good source to understand how bad the vulnerability really is and how it was exploited. It has a default rating as well, but most of the time, again, it lacks internal context, so we try to pull more vulnerability data. So we pull data from Red Hat, we pull data from NVD, any open source solution or vendor open source solution that is out there that provides information about the CVE, we collect and centralize in our risk framework. All of this data collection just makes us understand the vulnerability better instead of relying on the default scores that the scanners give us.
Third step, reporting and remediation. So now that all that information is passed to our reporting service. The reporting service doesn't have to care about the scanner source, the vulnerability type. All it needs is the UUID to create tickets, track metrics, track asset owners, etc. And in the next section, I'll go into a lot more detail about the implementation details of our reporting service. And then lastly, verification. Our motto is trust but verify. People can try to fix something but then make a mistake. We want to rely on programmatic verification to feel really confident that it's actually no longer present in our infrastructure. And here, this is where we use the UUID again. If our scanners aren't outputting it, we can conclude that it's no longer present and we can verify it as fixed. Or we can use internal infrastructure metadata to write our own code determining if something is fixed or not. All right, so that's the general process. How do we scale to more easily integrate even like many vulnerability sources into our process? As mentioned earlier, what ties this together is the reporting service we built. So quick basic architecture for context. We are an AWS cloud company, and we primarily operate on service-oriented architecture. So a big asset use case for us are managing microservices. If you're interested, there's a lot of different blog posts on our tech blog posts discussing our infrastructure, if you're curious.
A little bit also about the tech stack. So as we told you, we automated this entire process using the following. So we leverage vendor APIs. We try to stay away from dashboards, et cetera, pulling the API, using the data that we are most interested in, and feeding that into our platform as part of our metadata collection. Also, Apache Airflow. Anyone here familiar with Apache Airflow out of curiosity? Cool, yay, one person. So actually, Apache Airflow is open source. You should all look into it if you're interested. If you're not familiar with it, it's basically a data management platform that lets you handle large data sets. So especially as you deal with large vulnerability streams, you need something robust that constantly allows you to handle and manage this data. We have open sourced it, and you should definitely look into it. And we have also a blog post about it. Another thing that we also use is Hive and Presto, because as I said, it's important for you to centralize this metadata and build your own vulnerability database. So we use Hive and Presto to store our data. And for reporting, we use Jira. But again, everything that you see here, we really try to build a system that is vendor agnostic. So you can actually build something that works for your environment with other open source solutions that we'll talk about in a little bit.
Yeah, the implementation we're talking about is not meant that this has to be in this tech stack. There's multiple ways to solve this problem. All right, so how it works. So we have a client, and they write code to standardize the vulnerabilities found from a scanner or otherwise, and then calculate the adjusted risk. Then all the client has to do is provide it to the reporting service in the expected format. And after that, the service handles all the heavy lifting. So it unifies shared logic like ticket creation, finding the asset owner, tracking metrics. It can handle things like deduplication. The asset or the vulnerability owner doesn't have to worry about accidentally reporting something twice because the service tracks if something has been reported or not. And then, so it's idempotent. You don't have to worry about duplicating tickets. And then this makes it really easy to scale with any type of vulnerability you want to start tracking. The functionality is modular. Anyone can write code ingesting this vulnerability data and then integrate with our reporting service to handle the rest. This has made our process significantly more efficient. We're no longer the blockers for tracking vulnerabilities. We don't have to be responsible for every single scanner in use. We just have to provide support for the reporting service. This means we also don't have to make a bespoke flow per scanner, per vulnerability type. We don't have a different reporting process for reporting insecure configurations versus CVEs. And once we deployed this, multiple teams were able to start using it immediately. And if a new vulnerability drops, we can start tracking it right away.
So we told you about this platform, and we obviously didn't want to make something up that is not true. So let's talk about the results. This is not a Bitcoin chart. We're just not allowed to talk about. Our legal team didn't allow us to actually add numbers to the chart, but I promise you, trust this random person on this stage. We did drive down the risk. I mean, not the risk, but we drove down the false positives to the appropriate, to represent the actual risk. And again, when you look at this chart, I just want you to remember that by reducing or having a better understanding of your risk, you can focus on the highest priority and most critical vulnerabilities in your environment instead of bombarding individuals with nonsense vulnerabilities or vulnerabilities that are maybe not as critical in your environment, and have them focus on what's actually important.
And so a practical use case scenario, how we use this to tackle Log4Shell quickly. So yeah. Log4Shell happened, as is holiday tradition, over the break. What did we do? First step, we wrote an ingest DAG. A DAG is part of the Airflow architecture of a task you do for processing data. So we quickly wrote code to track all our Java microservices that needed to be patched. Then we plugged that into the reporting pipeline, which then pulled in that list, created tickets for all service owners, along with remediation action items. Then the service owners got the ticket, and they worked to deploy the patch and close it as fixed. Simultaneously, on our end, we use deploy data to actually look to see if the patch was correctly applied to a service. So that meant that when someone closed a ticket as fixed, if we detected that there was actually a mistake in what they did, we were able to reopen it and let them know what was missing, or give them help on actually doing it correctly. So wanted to provide this as an example of how building a scalable vulnerability management platform allows you to quickly respond to new types of vulnerabilities and think creatively in your solutions. If a vuln is falling outside of your standard scanning flow, you don't have to create a whole new system to track it. You don't have to rely on the default data provided by whatever vendor you may be using to scan. You can use many sources to help you. In our case, it was significantly faster to use our internal metadata to find all usages of the library and how to know if something was fixed programmatically. And so if we had only relied on a default pipeline that wouldn't let you customize, we would have had to have done everything manually, keeping the vulnerability active for longer. And so this can help you think about what the metadata you store already and how you can leverage it. Building a vendor-agnostic solution allows you to think creatively. So we've been talking a lot about this vendor-agnostic solution here. To be clear, we're not saying that vendor solutions are bad or that you should drop your multi-year contract with one, but rather rethink the way vendors are fitting into your ecosystem.
So you should design for your infrastructure, not for a vendor. So don't rely too much on vendors. Build a pipeline where you can easily plug in a new tool and remove it if necessary without really affecting your security. Make sure that you also leverage APIs instead of using out-of-the-box deployments, because the worst thing that would happen is that you give thousands of engineers access to a dashboard with your most sensitive data. So you can really just massage the data based on the data that you collect from the vendor API. Also, explore non-traditional open source solutions or security solutions. For instance, I mentioned Apache Airflow, or we use OS Query. So instead of deploying more and more tools, we're leveraging existing agents that maybe other teams are using. For instance, if you have an SRE team or a DevOps team, look at their agents and tools that they're using, and maybe you can collect metadata from them. And think about it this way: every time you implement a new tool in your environment, you increase the attack surface. We all learned about supply chain vulnerabilities, so leveraging maybe something that is already in place will help you minimize the risk a little bit. Also, pull vulnerability scoring data from multiple sources. Don't just rely on what NVD is telling you or the default CVS scores. Make sure that you pull as much information as you can in your metadata collection, and then you will get a better risk score or a better signal in the risk score as well. So as I mentioned, there are a couple of open source solutions that you can use in order to build your own platform. So these are a bunch of open source solutions that you can look into that, again, do provide an API or at least can help you automate your environment. Some of them were open source by Google, Trail of Bits by Airbnb. Definitely encourage you all to look into it. So takeaways, what do we want you to take away from this talk? So first of all, collect metadata. Everything that you have in your environment, just take it. Just take it. You can do something with it. So, or for instance, if you don't have a robust asset inventory, maybe make sure that you can integrate a system where asset owners can fill in their own asset information, for instance, which business units they belong to, and et cetera, et cetera. So make sure that you require asset owners to be a little bit more proactive. Also, as I mentioned, proactively collect vulnerability risk data and start tracking ownership. For instance, you can also use machine learning to predict who the owner of the vulnerability could potentially be. Also, centralize all of the vulnerabilities. most of the times, all of the companies tend to use multiple solutions, security solutions, and each of them tend to have their own report, their own dashboard, etc. But how do you actually centralize all of this data to understand the risk in your environment? So again, leverage the APIs and feed all of this data in a centralized internal database where you can be in charge of the data, and where you can also standardize the format a little bit. And standardizing the format will also allow you to build on top of it and expand regardless of the vendor limitations. And yeah, and invest in automation. So if you remember this awesome slide with all of the noise and the bottleneck on the bottom, move away from that model. Again, invest in automation because you don't want to take away from critical remediation time. And focus on root cause prevention. So instead of just putting the Band-Aid on and patch the vulnerability as it goes, no, try to fix or have a system that understands the root cause and you address actually the root cause of the vulnerability. Whether that's maybe a new design, your architecture, whatever it is, you have to be aware of what you need to do on the root cause level. Yeah, and then move away from the traditional vulnerability management approach. It does not make sense especially for companies, to just rely on one person to triage vulnerabilities and pass them to remediation owners, especially because security needs friends, and it doesn't make sense to constantly just share random, big, noisy vulnerability reports with others. Don't be a bottleneck. So a couple of acknowledgements. First of all, I want to thank Keziah, which I didn't mention her name. When I started building this at Airbnb, I was nowhere with my software engineering skills like Keziah. She took it to the next level, so thank you, Keziah. I also want to thank Hacktivity and the entire team here and everyone who's been dropping 0 days here and all the hackers, so thanks to the community for letting us speak. And quickly, Diana, Derek, Jawei, Tina, Chris, and Mark, who are in San Francisco, thank you for helping us with this talk.
Yeah, and I also wanted to counter shout out Kadia, because I was traditionally trained as a software engineer, and so I've just been able to learn so much about security from her.
Well, yeah, hi. So, questions?
And we have some contact information as well if you're ever interested in reaching out to us.
Thank you both very much. Do we have any questions for Keziah or Kadia at this time? Okay, it would appear not. That's not unusual. Don't be alarmed. The speakers will be around today and tomorrow.
Yeah, we'll be here.
So you can approach them with questions.
Yeah. And we also have a blog post if you're interested, and a bunch of tools that are open source. So I definitely encourage you to look into it.
Okay, so again, Keziah, Kadia, thank you very much.
Thank you.